Today, I'm going to explain another relationship in gas behavior. The relationship between temperature and the volume of the gas. Or we call it the Charles law. Charles law explains the relationship between the gas volume and the gas temperature. This relationship is directly proportional. What does it mean, the word directly proportional? They increase with each other or decrease with each other. Like, for example, if the temperature of the gas increases, temperature, its volume also what? Increases. And the opposite is correct. If the temperature decreases, its volume also decreases. Okay? Let's take this simple experiment. If you bring a balloon filled with air and you put it in ice, the balloon will what? Will shrink, means its volume decreases. When you put it in ice, what about the temperature of the gas inside the balloon? Will increase or decrease? Decrease. And for this reason, its volume also decreases. Okay? So this is the relationship between temperature and the volume of the gas, which is directly proportional, or we call it Charles law. By this way, look, a gas-filled balloon is at room temperature. Means this balloon is filled with gas at room temperature. So the temperature of the gas inside this balloon is 20 Celsius. It's okay. The balloon is submerged into the liquid nitrogen. I will bring this balloon and submerge it into liquid nitrogen. Liquid nitrogen, its temperature is what? Minus 196. Look what happened to it. Its volume what? Decreases, yes? Or collapse, yes. Why? Because the temperature of the gas inside the balloon decreases, so its volume decreases. The balloon is removed from the liquid nitrogen. I will take it out from the liquid nitrogen. What happened to the air inside the balloon? It will gradually increases. What happened to the temperature of the air inside the balloon? The temperature of the air gradually what? Increases. So what will happen to the volume of the balloon? It also gradually what? Increases until it returns to its original state. So here, temperature, okay, here, temperature increases, okay, volume increases, temperature decreases, volume what? Decreases. Temperature increases by this way. When the arrow pointed toward up means increases. So temperature increases, volume what? Also increases. Temperature decreases, volume decreases. And so on. But in this case, what about the pressure? In general, if I wanted to make a relationship between two parameters, in gas, I have to make the third one constant. Means what? If I wanted to make a relationship between temperature and the volume, the pressure must be what? Constant. The pressure must be what? Constant. And the opposite is correct. How? If I wanted to make a relationship between temperature and the pressure, which one must be constant? Volume must be constant. You understand?
Yeah.
Okay, so if you wanted to construct any relationship between two parameters in gas, the third one must be what? Constant. The third one must be what? Constant. This is the Charles law by a simple way. Thank you. Between temperature and the speed of particles. What could you see here? You see thermometer that measure temperature and the particles of the gas. Here, when the temperature is 5, here, temperature is 5 Celsius. Look to the speed of particles. When the temperature increases to be 20 Celsius, look to the speed of particles increases or not. When the temperature reaches to be 40 Celsius, look to the temperature, look to the speed of particles. So, who can tell me the relationship between temperature and the speed of particles directly or inversely? Directly or inversely, the relationship between directly means they increases with each other or decreases with each other. Yes, but it's okay. When the speed of particles increases, what about the pressure? Here, the pressure here is low. The pressure here is moderate, for example. And the pressure here is what? High. So who can tell me the relationship between temperature and the pressure of gas? Is directly or inversely? Directly means, so, more temperature, more speed of particles, and more pressure. And more what? Pressure. Thank you. What could you see here? You can see a cylinder, have a piston, and gas. Here I will explain the relationship between temperature and the pressure. Yes. In this one, no heat. So here, low pressure. Very low pressure. So the piston position will be here. When you add some heat, what about the particles of gas? Their speed increases. The particles' speed increase. So the pressure what? Increase. And when the pressure increases, the pressure of the gas will push the piston up. If you add more heat, this means more pressure. And the more pressure will push the piston up. Yes, so look here. Low temperature, low pressure. Okay, here. Moderate temperature, moderate pressure. High temperature, high pressure. Thank you.